Let's now discuss how we use logarithms to help us solve equations that include a base of e, Euler's number. If the base of one or both sides of an equation is e, then the natural logarithm can be used to bring the exponent to the coefficient. So early in the chapter, we discussed the inverse rule of logarithms. If we have a logarithmic function first and an exponential function second, these are inverse functions, which means they will cancel each other out, leaving us with whatever is left in the exponent of the exponential function, which in this case would be x. So if you have a base of e, you can use a log of base e to negate this base and bring this x down. A log of base e is the same as the natural log. So if you have a base of e, you apply the natural logarithm to both sides to cancel the base and bring this exponent down. So let's take this inverse rule and walk through an example together. You'll be asked to solve for x and check the answer. And we have e to a power of 5x is equal to 10. So how do we go about solving for x here? Step 1, make each base the argument of a natural logarithm. So that would give us the natural log of e to a power of 5x is equal to the natural log of 10. The natural log and this base e cancel each other out, which allow us to set the exponent 5x equal to the opposite side of the equation, giving us 5x is equal to the natural log of 10. And now we can solve for x. So we'll divide both sides by 5, showing us that x is equal to the natural log of 10 divided by 5. And if you plug this into your calculator, you'll find that x is equal to 0.46. And we can check this answer by plugging it into the original equation for x here. So when we do so, that would give us e raised to a power of 5 times 0.46, which would be 2.3. And e raised to a power of 2.3 is equal to 10, giving us 10 is equal to 10, confirming that x is equal to 0.46. And that is how we would go about using natural logs to solve exponential equations. Let's now have you try a few practice questions. Solve for x and check the answer. Question number 1. E to a power of x minus 4 is equal to 9. Question number 2. 3 times e to a power of 2x plus 1 minus 8 is equal to 4. And question number 3. 5 times e to a power of 3x plus 2 plus 6 is equal to 11. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We want to solve for x in e to a power of x minus 4 is equal to 9. Step 1, we want to make each base the argument of a natural logarithm, which would give us the natural log of e to a power of x minus 4 is equal to the natural log of 9. And now the natural log and e here cancel each other out, allowing us to set the exponent, x minus 4, equal to the opposite side of the equation, the natural log of 9. And now we can solve for x. So we can add 4 to both sides, showing us that x is equal to the natural log of 9 plus 4. And if we plug this into our calculator, we find that x is equal to 6.2. And we can check the answer by plugging 6.2 into the original equation for x here, which would give us e to a power of 6.2 minus 4, which would be 2.2. And e raised to a power of 2.2 is equal to 9, confirming that x is equal to 6.2. So that is the answer to question number 1. Let's now have a look at question number 2. We have 3 times e to a power of 2x plus 1 minus 8 is equal to 4. So the first thing we want to do is isolate the exponential term here. So we'll begin by adding 8 to both sides, showing us that 3 times e to 2x plus 1 is equal to 4 plus 8, which is 12. And now we can remove this coefficient of 3 by dividing both sides by 3, showing us that e to the power of 2x plus 1 is equal to 12 divided by 3, which is 4. And now we can use this expression to help us solve for x. So step 2, we'll make each base the argument of a natural logarithm, which will give us the natural log of e to a power of 2x plus 1 is equal to the natural log of 4. And over here, the natural log and e cancel each other out, which allows us to set the exponent 2x plus 1 equal to the opposite side of the equation, the natural log of 4. So we have 2x plus 1 is equal to the natural log of 4. So now we can solve for x. So we'll subtract 1 from both sides, showing us 2x is equal to the natural log of 4 minus 1. Here we can solve for x by dividing both sides by 2, showing us x is equal to the natural log of 4 minus 1 divided by 2. And if we plug this into our calculator, we find that x is equal to 0.19. And we can check the answer by plugging it into the original equation. 3 times e to a power of 2x plus 1 minus 8 is equal to 4. So we'll plug in 0.19 in for x. So in this exponent, we have 2 times 0.19, which would be 0.38, plus 1 would give us 1.38. And e raised to a power of 1.38 is approximately 4. 3 times 4 is 12, giving us 12 minus 8, which is 4. And 4 is equal to 4 confirms that x does equal 0.19. So that is the answer to question number 2. Let's now have a look at question number 3. We're given 5 times e to a power of 3x plus 2 plus 6 is equal to 11. So step 1, isolate the exponential term. So we want to begin by subtracting 6 from both sides, giving us 5 times e to a power of 3x plus 2 is equal to 11 minus 6, which is 5. And now we remove this coefficient of 5 by dividing both sides by 5, showing us e to a power of 3x plus 2 is equal to 5 divided by 5, which is 1. And now we can use this expression to help us solve for x. So step 2, we want to make each base the argument of a natural logarithm. So that would give us the natural log of e to a power of 3x plus 2 is equal to the natural log of 1. And the natural log and e on the left side cancel each other out, which allows us to set the exponent 3x plus 2 equal to the opposite side of the equation, the natural log of 1. And now we can solve for x here. So we can first swap out the natural log of 1 for its equivalent value of 0. And now we can subtract 2 from both sides, which will give us 3x is equal to 0 minus 2, which is negative 2. And to remove this coefficient of 3, we'll divide both sides by 3, showing us x is equal to negative 2/3, or x is equal to negative 0.67. And we can check the answer by plugging it into the original equation. So when we plug in negative 0.67, we get 3 times negative 2/3, which would be negative 2, plus 2. E raised to a power of 0 is 1. So we get 5 times 1. And 5 times 1 is 5. Plus 6 would give us 11. And 11 is equal to 11 confirms that x does equal negative 2/3 or negative 0.67.